Good afternoon, friends. We meet once again to continue with our session of coplanar forces, and we'll continue with the non-concurrent forces which we started last time. Last time we studied about moments and the Varignon's theorem. Today we will go further with the next concept of a couple. Let us see what we mean by a couple. Two forces having the same magnitude, parallel lines of action, and opposite in direction will form a couple. Let us look at this picture. Here you have one force F1, another force F2. Both of them are parallel, but they are opposite in direction. These two forces are said to form a couple. The two forces will have the same magnitude, mind well. Both these forces will have the same magnitude. If F is the magnitude, then F1 will also have a magnitude of F and F2 will also have a magnitude of F, but they are separated apart by a certain distance. The sum of the x and y components of these forces will obviously be 0, as both of them are having the same magnitude and they are parallel in direction but opposite in direction. Then the components x and y of F1 as well as of F2 are going to be in equal and opposite directions, and therefore the sum total of the x components will be 0, the sum total of the y components will be 0. The sum of their moments, on the other hand, will not be 0. Why will that be? Because there is a distance apart from these two forces, and if we look at any one of the points, say point A, what will happen is the effect of this force F1 about A. We have studied the concept of moment. F1 into D1 will form the moment M1 about A. Similarly, F2 into D2 will form the moment about A in the opposite direction. The sum total of these two moments is not going to be 0 as against the vertical and horizontal components. So therefore we can say that these two forces combined together will not be able to move the body either in the x direction or in the y direction, because the x and y components are negating each other. But because of the couple that is being formed by these two forces, they will be able to rotate the body in any particular direction. In which direction will they rotate is very simple to understand by taking your right hand thumb and finger. If you look at these two forces, here, this particular couple is trying to rotate the body in the anti-clockwise direction. If we had forces, a force couple system like this, then it would try to rotate the body in the clockwise direction. For our purpose, we are going to treat all anti-clockwise moments as positive and all clockwise moments as negative. So here we have the equation. The sum m of the moment F1 and F2 about A will be m equals F1 d1 minus F2 d2. Why plus and minus? One is going to cause an anti-clockwise moment, the other is going to cause a clockwise moment. The sum total is going to be F into d1 minus d2, which is effectively F into d, as we can see over here. So the couple will have a moment equal to F into d. The magnitude m is called the moment of the couple. The direction of the couple, as I said earlier, can be observed on the body itself as being clockwise or anti-clockwise by following the force couple system by your right hand thumb and forefinger. As we have already seen, this couple is going to rotate the body in this direction. Let us look at some more couples. Here we have a bracket, an angle, which has two parallel force systems acting on it. There is one force system like this, another force system like this. This is 200 newtons, each equal and opposite forces, and parallel to each other, therefore they are going to form a couple. They are separated by 50 mm. Similarly, we have another force system, 200, equal and opposite but parallel to each other, therefore another force couple system is being formed over here. Both of them are going to have the same magnitude moment m equals 200 into 50 mm, 200 into 50 mm. Both of them are going to try to rotate this particular body in which direction? In the anti-clockwise direction. See, this couple is going to rotate in the anti-clockwise direction. Similarly, this couple is trying to rotate in the anti-clockwise direction. This brings us to the concept of equivalent couples. If the couples have the same magnitude and the same sense in the sense whether they are clockwise or anti-clockwise, then they will be called equivalent couples. Here figure A, B and C. Each of these figures show different forces forming the couples. In this case, you have a 200 Newton force separated by 100 mm distance. The force direction is indicating that the couple is going to be in the anti-clockwise direction. The magnitude of the couple is going to be how much? 200 into 100, that is 20 into 10 raised to 3 Newton mm. Let us look at the second force couple system. Once again, here the forces are equal and opposite but different magnitude. Previously we had 200 newtons as the magnitude of the force. Now we have 100 newtons as the magnitude of the force, but at the same time they are separated by a distance of 200 mm, and therefore the moment that is caused by these forces is once again the same as the moment that was caused in case A. Let us look at the direction of this couple. This couple is trying to rotate the body in which direction? Once again in the anti-clockwise direction. Can we say that the couple in case A and the couple in case B are both equivalent couples? Because they have the same magnitude and they have the same direction. Let us look at the third set of the forces. Here they are not horizontal and vertical as in the previous cases, they are at some angle, but still they are parallel and opposite in direction. The magnitude is also the same for each force and therefore this forms a couple. Once again, if you look at the moment that this couple causes, it comes to the same value as in case of A and B. So A, B and C, all three are having different magnitudes of the forces, but because they are having the same value of the moment m in each case and the same direction, we can say that all three of them are equivalent couples. So having studied this much about couples, let us try to summarize what we mean by couples and what are the characteristics of a couple. If the sum of the forces forming a couple is 0, it should be 0 because the vertical and the horizontal components are going to negate each other because the forces are going to be equal and opposite in direction. But the sum of their moments about a point on the body will not be 0. A couple will not give a linear motion to the body. Why? Because both the horizontal and the vertical components are going to negate each other. If you have force F in this direction, but the moment m of the couple will have the same magnitude and same direction irrespective of its point of application. Let us understand what is meant by this. Supposing we look at this couple. The couple has the effect of rotating the body in the anti-clockwise direction by a magnitude 20 Newton meters. If I remove this couple from here and I apply it over here, mind well, not with the 100 Newton force, with the 200 Newton force. The same couple is being placed over here. What will happen? The body will still rotate in the anti-clockwise direction by a magnitude of 20 Newton meters. Therefore, the characteristic of the couple is that it will have absolutely the same effect wherever it is applied on any body. It is not specific to the point of application that the effect of a couple can be studied on the body. So, we can say that a couple can be applied anywhere on the body, but the rotation that it produces will be the same. We will understand this concept much better as we go ahead with the problems. The next characteristic of a couple cannot be balanced by a single force. Why? Because a couple itself is formed of two forces, two equal and opposite forces. So, if you say that here is a couple and there is another force which I am applying which is going to balance the couple, we are wrong. A single force cannot balance a couple. It can be balanced only by another couple. What should that couple be? It should have the same magnitude but opposite in direction to our original couple. And lastly, equivalent couples will have the same magnitude and direction even though the individual forces and their distances are different. We saw this in our previous case. This is one system of couple. This is another system of the couple. This is a third system. All of them have different magnitudes and different distances, and yet they have the same effect in terms of the moment and its direction, and therefore they are called equivalent couples. Having understood couple, let us also differentiate between moment and a couple, because we know that we have already studied what is a moment. A moment is the rotation that is caused by a particular force at a particular, when it is applied at a particular distance, whereas a couple is not a single force. It comprises of two forces. So, let us distinguish between a moment and a couple. The moment is produced by a single force with reference to an axis of rotation. You have to have an axis of rotation. It is absolutely required to define the axis of rotation when you talk about moments. Whereas, as we saw in case of couples, you do not need any reference point. Wherever you apply the couple on any body, it is going to have the same effect of rotation and same direction of rotation. Therefore, the couple is said to produce by a pair of unlike in the sense they are opposite, parallel forces, and does not depend on any reference point. Very different from moment. Moment has to have a reference point. Second, the magnitude and direction of a moment will vary with the point of reference. If you have a point of reference here and you are applying a force here, the moment caused will be different than if you apply the force here or here. Whereas in case of couples, the magnitude and direction of the couple will remain unchanged with reference to any point. Therefore, the vector formed by a couple is a free vector. It does not depend on a reference point, whereas the vector formed by a moment is a fixed vector because it depends on a reference point. Next, a moment can be balanced by another force, producing equal and opposite moment. Supposing you have a force which causes a clockwise moment of magnitude 100. Another force can cause an anti-clockwise moment having magnitude 100. Both of them can balance each other. Not so in case of a couple. A single force cannot balance a couple. A couple can be balanced only by a pair of forces, forming a couple which produces equal and opposite rotations. So, let us look at the example of a moment and a couple. Here is a classic example of a moment. There is a door. It has a particular reference point where you have the hinges. Now, with reference to this reference point, if we apply a force and we try to rotate the door can be opened or it can be closed. It will cause a couple. such a force cannot form a couple. Here you have a nail top, and you are trying to fix it by applying two equal and opposite forces in opposite directions. This forms a couple. So tightening of a bolt is an example of a couple. Closing of a door is an example of a moment. Let us look at a few examples to understand the concept of couples. Determine the moments caused by couple formed by 100 Newton force. Here is your 100 Newton force. Slightly tricky because it is at an inclination with the horizontal and the vertical axis. The 100 Newton force are parallel, opposite in direction, and have certain distance between them, and therefore they will definitely form a couple. The next part of the problem is, what is the moment caused by the couple of the 300 Newton forces? This is slightly simpler because they are parallel to the x-axis. We will go to part 2 first because it is simpler. If you draw the free body diagram, you have the 300 Newton force with a distance of 60 mm between them, and therefore the moment caused by this particular couple is going to be how much? 300 into 60, that is 18,000 Newton mm. What will be the direction of the couple? Very simple. This force is trying to cause in this direction, in this direction. What is the rotation caused by this particular couple? It is going to be in the anti-clockwise direction. So here is your answer. The first part is slightly tricky because you have the 100 Newton force which is inclined at an angle of 20 degrees with the horizontal. So one option would be try and find out the perpendicular distance between these two forces, which is you will have to go into all your trigonometry, sine and cos components and find out the perpendicular distance, and then 100 into that particular distance will be the moment of the couple. As you will see in the next part itself, a simpler way of doing this would be resolve this force into its components. Now your problem becomes simpler because you have couple formed by two components of the 100 Newton force. This is one couple and this is the second couple. So we leave this at this point. We won't discuss this